right? So let's look at Roman 4. What has been told to us in the rows 1, 3, 5, the bulbs are red in color. And in the rows 2, 4, and 6, the bulbs are green in color. So what does that mean? The bulbs which are in the odd-numbered rows, that's the first row, it's red. Third row, it's red. And fifth row, once again, it's red. All right. And they are put some dots to indicate that that pattern is continuing. So what's the pattern? In the odd-numbered rows, what we would see is red color bulbs. And in the even-numbered rows, what's there? There are green bulbs. So in the row number 2, it's going to be green, green, green. Then row number 4, it's going to be green, 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 and green here. And that pattern continues. Right. This bulb pattern consists of 65 rows. Show that the total number of red bulbs is 65 more than the total number of green balls or green bulbs. So how do we do this? So the plan is this. First, let's find out the total number of bulbs in this pattern. So what's the total number of bulbs in this pattern? How can we find out? Total, the moment you hear the word total, when it comes to arithmetic progression questions, what should come into your mind? The formula to find sum. What is it? Sn is equal to n over 2 times 2a plus n minus 1 d. All right. So then we are trying to find out the total number of bulbs in this pattern. So then how many rows are there in this pattern? 65 rows, which means if you write the number of bulbs in each row using commas, for example, 1, comma. This next row, that's 3. Next row is 5. Next one has 7, 9, and keeps on going. How many such terms are going to appear in the progression? There'll be 65 terms, right? So what we are supposed to find out is what's the addition of those 65 terms to find the total number of bulbs in 65 rows. So S65, the addition of the first 65 terms. So what's N? That's 65 over 2. 2A, that's 2 times the first term. What's the first term? That's 1. Plus, what's N? 65 minus 1. And what's the D? 3 minus 1 equals 2. We found out the D in previous questions too. For previous questions too, we had to use the D. You can get from that also. So now we get what? S65 equals 65 over 2. Then comes 2 times 1. What's 2 times 1? That's 2 plus 65 minus 1. That is 64 times 2. So S65 is equal to 65 over 2 within brackets. 64 times 2 is 128 plus 2 is 130. So there's no space to go downwards. So let me go side here. So X S65, S is for the sum. Sum is another word for addition. 65 over 2 times 130, 130. So we can multiply and divide, or we can cancel first, up to you. So 2 has 1, 2, and 130 has 65 twos. So what you get for S, what would you get for S65? 65 times 65. And what would it be? Check it. So when you multiply, you would have got 4,225. So what does that mean? In all 65 rows, there are 4,225 bulbs. So let's write here total number of bulbs. Total number of bulbs equals 4,225. All right. And now what's the next thing we are going to do? We are going to find the number of green bulbs. How can we find the number of green bulbs? All right, let's write the number of green bulbs. Let's list it down. Let's see whether we can see a particular pattern. So, second row has green bulbs. And how many bulbs are there? 3. And what's the next one? Fourth row. They have said green bulbs are there in even numbered rows. So how many green bulbs are there in the fourth row? 1, 2, 3, 4, 5, 6, 7. That is 7. And fifth row, rather sorry, it should be sixth row. The sixth row is to be seen, so we can count and get it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So now, when we write the number of bulbs in the even numbered rows, so let's write using commas. Check whether you can see a particular pattern. What is it forming? What type of a pattern is it forming? Isn't it an arithmetic progression? See, 7 minus 3. What is 7 minus 3? That's 4. And 11 minus 7, that 2 is 4. So what does that mean? When you take the number of bulbs in the even numbered rows and write as a sequence, that is forming an arithmetic progression. So how would you find the total number of green bulbs? You can use the formula for arithmetic progressions. All right. So what's 3 here? 3 is, now remember, this is not the this is not the arithmetic progression what we had earlier for the all the bulbs. This is a new arithmetic progression for the green bulbs. So what is it? 3 is the first term. 3 is the first term of this progression. And it is the number of bulbs in the second row. All right. Now, one thing that we have to find out initially is we have to find out altogether how many terms are going to come in this green color arithmetic progression I have written. What would be the number of terms? The last term, what would be the term number? How would we figure out that? it has been told to us this bulb pattern consists of 65 rows. So what's the even number that comes immediately before 65? That is 64. So what does that mean? Altogether, they're going to be, oh, what's the last even numbered row? It's the 64th row. So 64th row is, so we got to figure out 64 is which even number, because see, second row number of bulbs is represented by the first term. Now fourth row bulbs are represented by the second term, of the green color sequence. So 64th row bulbs will be represented by which term of the green color sequence? What do we do? We got to divide by 2. Or to put in another way, we have to find out 64 is which even number is 64. So which even number is 64? That's the 32nd. So what does that mean? This green color sequence or the progression will have 32 terms. 32 terms. So to find the total number of green bulbs, we have to find the addition of these 32 terms that's there in the green color arithmetic progression. So let's see how to do it. So let's start writing the formula. What's the formula? Is n equals n over 2 times 2a plus n minus 1 times d. There should be an n here. So then we are trying to find is what is 32 or sum of the 32 terms of this green color arithmetic progression. So 32 over 2, 2 times was the first term, that's 3 plus 32, n is 32 minus 1, and what's the d, the common difference of this green color progression? 7 minus 3. What is 7 minus 3? And that is 4. So we put 4. So S32 equals 32 over 2. 2 times 3 is 6 plus 32 minus 1 would be 31 times 4. So S32 of this green color progression equals 32 over 2, 6 plus 31 times 4 would give you 124. So that's going to be 32 over 2 times 130. All right, you can either cancel 2 and 32 and then do the multiplication, or else you also can do the multiplication and then divide by 2. Up to you. So 2 has 1, 2, and 32 has 16 twos. All right, so now you can calculate what is 16 times 130 is. So when we do the multiplication, we get S32 as 2080. So that's the number of green bulbs. So number of green bulbs equals 2080. All right, so what's next to be done? So now we know the total number of bulbs, and we also know the number of green bulbs. So what's next to be done? We got to find out the number of red bulbs. So number of red bulbs. So how would we figure out what's the number of red bulbs? The total is 4,225 and green is 2,080. So from 4,225, let's subtract 2080 to find the number of red bulbs. What would it give us when we subtract? So that's 2,145 red bulbs. Now, what are they asking us to show? Show that the total number of red bulbs is 65 more than the total number of green bulbs. So we have to check for the gap, or we have to show that the difference between the number of red bulbs and the green bulbs is 65. So how do you find a difference? What do we use? We got to use subtraction. So subtraction, what to be subtracted? Number of red bulbs minus subtract what? Number of green bulbs. So number of red bulbs we have found out 2,145. Then comes subtraction. The number of green bulbs. How much is that? 2,080. So when we subtract, what do we get? We get 5, 6, 65. So we have proven that the difference between number of red bulbs and green bulbs is 65. All right, so that's it with this question.